Let's go through some set notation. So remember, this symbol here means number of elements in this case, specifically A. So if I wanted to know the number in A, well, we would just count 1, 2. There's 2 elements in A. If I wanted to know my number in B, well, I'd go 1, 2, 3. There's 3 elements in B. Number in my universe, well, there's 1, 2, 3, 4, 5. So this is always just equals a specific number. This one means is an element of. So I could say 2 is an element of A. I could say 3 is an element of B. When we put a line through it, we'd say is not an element of. So I could say 5 is not an element of A. I could say, same thing, 5 is not an element of B. Okay, this symbol here means complement. And it's the English word not. So you'd say everything not in A. So it's everything that belongs to the universe but not in A. So for example, well, A has 2 and 4, has 2 and 4. So that means not A has 1, 3, and 5. If I wanted to do not B, well, B has 1, 2, 3, so 1, 2, 3 is gone, so not B is just 4 and 5. This guy here just means the empty set. We could use the 0 with the slash through it, or just 2 braces with nothing in between. It means nothing belongs to that set. This here, that kind of looks like a U. Remember, this just means union. And it's the English word or. So it's everything in A or B. So if I wanted A union B, well, I need everything in A, which is 2 and 4. Then I'd need to grab everything else that's in B. So I've already accounted for the 2, so I just need the 1 and the 3. So I don't care if it comes from A, I don't care if it comes from B. If it shows up in one of them, it shows up in the union. This guy here is, remember, kind of looks like at the N, it's intersection. It's the English word and it's what's common. In A and B. So if I wanted to find A intersect B, I need the thing that shows up in both. Well, the only thing that shows up in both of these is the number 2. And this last symbol here, this is subset. So if I say that A is a subset of the universe, it means everything in A came from U. So this is always the smaller set or the exact same size. And this is where we got our elements. All right. So remember, some of these symbols are on your formula sheet, some of them aren't. So you just need to be able to make note of which are which and how you're going to be able to find them or understand them later on. All right. Venn diagrams with two sets. So we're going to look at the different parts. So Venn diagrams, remember, always start with the universe, which is a rectangle. Then let's say I have A here, B here. And I have, let's label these parts. This is going to be region 1, region 2, region 3, region 4. So if I wanted to find A intersect B, well, that's going to be region 3. So whatever in this region 3, that's my intersection. If I wanted A union B, well, that means I need to belong into A or B or both. So that's going to be 2, 3, and 4. If I'm in A, well, that's going to be 2 and 3. If I'm in B, that's going to be 3 and 4. If we stick the word only, if I'm in only A, this is 2. Same thing as saying in A, but not B. Again, I can do this with B. If I'm only B, that's going to be 4. And we'd say in B, but not A. I could also say A union B not or complement, just the same as A complement intersect B complement. And this is region 1. This is our universe. I could have A intersect B complement, which is the same as A complement union B complement. And this is going to be regions 1, 2, and 4. So the most important thing with Venn diagrams of two sets is knowing where to look. What regions am I looking at to answer my specific question? Principle of inclusion and exclusion. This is just for any two sets A and B. The number of elements in A or B is equal to the number of elements in A plus the number of elements in B minus the number of elements in A and B. So remember, we have to take away that intersection so we don't count the overlap twice. So if we look for our example here, well, the number of elements in AUB, we already did that down here. So the number of elements in AUB, that was 1, 2, 3, 4. Remember, this is A union B. So 4 is equal to, if we do the number of elements in A, well, we said the number of elements in A is 2. Plus the number of elements in B. Well, the number of elements in B, like we said here, is 3. And we have to subtract out the number of elements in A and B, which is down here, that is 1. And it is a true fact that 4 equals 2 plus 3 is 5 minus 1 is 4. So we have to take that overlap or else I end up counting that 2 twice. So if I just go number of elements in A plus B, well, I'd say there's 1, 2 here, 1, 2, 3 here, so there's 5 in total. But I would have counted that 2 twice. Just like with 2 sets Venn diagrams, 3 sets Venn diagrams, it's very important to know where you're looking. So if I have my 3 circles here, I have A, B, C. There's a difference between if I want A intersect B and I want A intersect B only. Remember that keyword only. So if I want A intersect B, that's going to be this whole petal here. I want to be in A and I want to be in B at the exact same time. If I want A intersect B only, it means I don't want to be part of C. I just want to be part of A and B. So that would be this part of the petal here. So be aware of that part only and know where you're looking at. If I'm looking at, I just want to be part of C only, well, C only would be just the parts that are in C. But if I wanted to be C, well, C would be that whole circle. So if I wanted to be C, doesn't matter if I'm part of any other group, as long as I fall into the C circle. So be very careful where you're looking at with these 3 set Venn diagrams. When it comes to problem solving, well, you're always going to use your Venn diagram. So you're going to draw and organize information into your Venn diagram. And remember, whenever you're filling out your Venn diagram, you always want to start from the center and work your way out. You always want to make sure that you're removing that center from everything else so you're not counting it twice. Beware of that word only if it has the word only. We can write it directly into our Venn diagram. All right. So you want to then, once you have your Venn diagram filled out, really you just want to read the question very carefully to figure out what part of the Venn diagram you're looking for. So you're going to read question carefully. And locate the section on the Venn diagram. So taking your time to properly fill out the Venn diagram is going to help you no matter what the question is. All right. And remember, for this one, we need a clean Venn diagram. Do not show any work on your Venn diagram. All your work is to be shown on the side, and your Venn diagram should have numbers only. All right, there we have it. That is all of our information for set theory. Go ahead and try the questions below. If you find something else that you needed to remember and add to this brain dump, feel free to add it. This is just a general idea.